Hello everyone, welcome back to the video on SCP plugin in QGIS. We will continue our task on performing image classification on a Landsat 8 data over our study area. In the previous video, you saw uh, how to clip the Landsat 8 data to our study area and performed radiometric calibration to convert digital number to top of the atmosphere reflectance. We will continue from here. Make sure that your SCP user interface is open and your band set is set with the latest RT underscore clip bands B2 to B7. Once you have this ready, you can use all the functionalities in this toolbar to add training sites. Before we do that, let's change the bands into a combination, preferably a false color combination. So for that, you can go here and select the combination you want. So let's try 432, which is the false color composite actually. So here you can see the false color composite of the Landsat 8 image. You just have to select it here and the SCP will automatically create it. Now let's go to the training input where we will create training sites for each of the land cover types we want to classify. The first step is to save a empty training site file. So I'm going to name it as training underscore because it's June 2015, saying meaning okay, it's a training sites for an image dated 6 June 2015. You can name it anything but give a sensible name. Okay, so it's saved. I'll save the project in between. Now you can see that there's an empty table where we have to add polygons representing each land cover map. So there are two functionalities here. One is create a ROI polygon and another one is activate a ROI pointer. So this one is to manually create the polygon representing a land cover type, and this tool is to use region growing algorithm to create polygon for a particular land cover type. Now I would like to refer back to our presentation on exercise to check the land cover types we want to classify. As I've already explained, SCP follow two classes, macro classes and classes. This is the fine level of classes and this is the general classes. For to make it easier in this video, let's start with the water bodies. SCP always look at this combination of numbers. So 1 will represent open forest under forest, 1 2 will represent dense forest under forest. In that way, 4 6 represent permanent water in water bodies, etc. So you should this design of the land cover types is very important, and once you fix it, you should not change it because SCP will follow the same pattern to classify the image. So let's draw training samples for water bodies. In water bodies, the class permanent water. So this area, it looks like a permanent water. And if you are in doubt, you can always switch off these individual bands because we have the FCC combination here. And you can always switch on the quick map services of Google Satellite here so that we always have a high resolution background where you can see much more things than a Landsat to make sure that okay, you are drawing it correctly. Okay, coming back to the Landsat, but there will be always a shift between Google satellite layer and Landsat image, so you have to be careful when drawing with reference only to Google satellite. So here I want to draw a training sample here, training set here. So I will I will do a manual polygon. I'll click here. So you can draw using left click and finish it using right click here. So this is my first water polygon. And here, as I said, this is 4 macro class 4 and class 6. So here it is asking for MCID, which is a micro class. So we'll add 4 and class ID is 6. You can also give name here, water bodies, and you can set permanent water. Once you add all your inputs, you can click on this table, just save temporary ROA to training input. Then you can see that it's added as a row here in the table, and it will be saved into this file as well. Now let us add a training site for dense forest area. So this is a dense forest area, this bright red. You can also verify that with Google Earth, sorry, Google Satellite layer, or also you can try different combination. Yeah, but I always prefer false color composite. Now checking back the combination, we know that it's in the forest 1 and 2, it's dense forest. So I want to create a training sample for dense forest. So I will again go back to my ROI tool, left click and right click, and it's 1 and it's 2 and forest, and class is dense forest. I'm just giving you an example how to do it. You have to add many more training sites distributed all over this image. Otherwise, the classification will be biased. The results will be bad. So make sure that you add more and more permanent water again and again. So for example, uh, here you can see that once I add 1 and 2, it automatically graduate to 3 here, expecting that you will add another one for 1 3, but you have to manually edit it. For example, here it's again a dense forest. So what I will do is prepare this, and I will change it back to 1 2 because 1 2 is forest and dense forest, and add another training sample for dense. So you can see that here there are 2 training samples now for the same combination 1 2 1 2. Now let's create a training sample for shallow water. This light blue is supposed to be shallow water. Then I will use again plugin, sorry, polygon draw tool. So for shallow water, the combination is 4 and 7. So I will add 4 here, 7 here, water bodies, and shallow water. So I added a training sample for shallow water, and these areas are this bright red, the plains. They are agriculture, which with the crops matured, matured crops, green, very green crops. That's why it is bright red in color. So and that class is cropland agriculture, which is 2 4. So I will draw a polygon here, which is 2, sorry, 4, and agriculture. Like this, you have to add many more on each class combinations. Then only you will be able to get a good accuracy on your map. You can adjust the um, You can adjust the stretch of the image using these two buttons so that you will get a bit more darker here. Yes. Now let's go to this water body. Let's try this region growing part. I want to create one for 10 permanent water. I will use the region growing. You select this tool and just click on where you are sure that that belongs to that particular class. In this case, permanent water. So if I click, then it will automatically select all the homogeneous pixels. So this is very helpful, very useful, but you have to make sure that it's not overestimating the pixels. You may have to adjust these values, maybe sometimes 0.005, for example, if it is overestimating. So you may have to play with this value, but in this case it worked very well. So again, this is for water, permanent water, 4 and 6, 4 and 6. um, so water bodies, I think in the previous one I made a mistake, but it's okay. Permanent water. So you added one more thing, and you can go to different tabs here. Here the macro class will show you different classes: water bodies, forest, and cropland. And in the ROE signature list, you will see all the one. You can change the color of the classes here. So you have to double click here. You can say permanent water, dense forest. You can put to green, green, shallow water into a light blue, agriculture, permanent water again the same color. Now, to give you an overview, so this is not complete. You have to work more on this and add more signatures. But there are many other features which I would like to show you here. One is to add highlighter signatures. So if you want to see a signature plot, spectral signature plot between different bands, for example, between dense forest and permanent water. So you can see the signature plot here. See how it varies over the band. These are two very distinct signatures, so it looks good. So the classification should be okay here. So this is how you will assess your training samples. So when you write your report, you also have to present some of these results. Um, Here another measure which can be used to assess the training sites is spectral distances. So you can click on calculate spectral distances here, and it will show you the spectral distance between dense forest and permanent water, depending on the training sites you have drawn. So here you can see that, for example, the Bray-Curtis similarity 55 means if these two training sites are distinct. If it is close to 100, it means they are similar. They cannot be distinct. So you may have to merge them or redraw them. Details about these four indicators are given in the SCP tutorial, which I have already shared with you, the PDF file. So this is how you will assess your signatures. You can also add all the classes: permanent water, shallow water, agriculture, and you want to see how it, sorry, this one, and you want to see how it varies over wavelengths. See here, all the classes are added. You can do the signatures, sorry, spectral distances again. Here you can see a red color, which means, okay, these two signatures you have to recheck again between shallow water and permanent water. That means they are similar. So maybe the classification algorithm may not be able to distinguish between them. So this is how you will assess your training sites. Here you can see one more red one between permanent water and permanent water, which is fine because they both belong to the same class. So that means you can actually merge these two. And to merge, you can come here, select the training samples you want to merge using the control button, and press merge. So here you can merge and delete the individual ones and clean it up. So um, by the end of all the training site, collecting all the trainings, you will have hundreds of training sites here, and you will be able to manage by merging and cleaning it up like this. You can also look at the scatter plot between two bands here for different classes and see if they are distinct enough or not. Now imagine you have prepared your training sites well, and now you want to have a quick preview on how the classification will look like. So we can go to the classification tab and select the algorithm you want. So SCP offers three algorithms: minimum distance, maximum likelihood, and spectral angle mapping. Maximum likelihood is the most popular and most used, but uh, I recommend you to try all three of them and see compare the results. And you can classify based on macro class ID or class ID. So you can classify it into um, 8 classes or 5 classes. Both are possible here. You just have to select which one you want. You can avoid LCS here, and then and once you have this, you can try how your classification will look like with the preview button. So you can switch on and it will show you how the classification will look like. Obviously my classification will not be good because I haven't added a lot of training sites, just for demonstration purpose. So this is how you will see your previews. Once you are happy with your classification preview, you can go back here and you can run your classification. So you can run here. You can also click on classification report, which will give you area report, and here you can give the name of the diff, classification max likelihood, and it will execute the classification. Okay, it's taking some time. Okay, so the maximum likelihood classification is ready here, and it's showing the results here.